So the first problem here, 10 over 3y minus 5 over 2y equals 1/4. Okay, so this is a rational expression, rational expression, rational expression. So that's what we call a rational equation. Now, what makes this problem tougher to deal with? What would you guys say? It has, okay, it has unlike denominators. I would say even more general, it has fractions. Like, I don't like dealing with fractions, do you? But there is a way to deal with them, just like you've done with numerical fractions. There's a way to get rid of the denominator in an equation, okay? Have we had equations in this chapter yet? Does anyone know? Have we had equations to solve for? No. So the method I'm going to use here is different because I have an equation, and I have properties of equality, okay? So the first property of equality that we are going to use is the multiplicative property of equality. You're like, what? Can I multiply both sides by the same thing? Am I allowed to do that? Multiply this side by the same thing as I do this side? Okay, that's allowed. That's a valid equality property. So my first step here is to multiply each term, so that means both sides, each term, by the LC, what do you guys think? D. So you remember LCD? Did we use that before? Yeah. We used it on non-equation problems, and we're now using it for equation problems. Multiply each term by the LCD. So can anyone tell me what the LCD of these three fractions is? What's the LCD? What's the numerical part of it, the number part? 12. What's the variable part of it? Y. Okay, so 3y, 2y, and 4, the LCD is 12y. Okay, that's the LCD. So I'm going to multiply each term by the LCD, and you're like, why would you do that? Well, you're going to see something that happens in the next screen that I'm going to put here. It's going to make the problem easier. You ready for it to be easier? I mean, really easy, which is really cool. Okay, everyone done with this? Because I'm going to move on. All right. I want you to show me this word because I want you to be very careful when you multiply everything by the LCD. So this is what I have. And I'll write it down. You write it with me, and I'll show you how I got all this. Because you might think, what? But just write it down. Maybe we can get it together. So 12y was LCD. I'm going to multiply by the first term, which was 10 over 3y. I'm going to multiply 12y by the second term, which is 5 over 2y. And I'm going to multiply 12y by the last term, which is 1/4. And you're like, what? What just happened here? What did you just add here? Well, I didn't add anything. I actually multiplied everything by the same number, which is allowed. Okay, do you guys see the original equations right here? 10 over 3y minus 5 over 2y equals 1/4. Do you see that original equation? And then do you see that 12y is being multiplied by all of them? You're like, why would you do this? Well, let's look at the first term right here. So this term right here, which is my second step. Simplify. So now that I multiplied everything by 12y, simplify. I spelled that wrong because I'm spelling this. Each term. Simplify each term. So is this as simple as it could be, this term right here? No. Do you guys remember in lesson -2, you had to multiply rational expressions? So you could say it's like that, and you're multiplying. So what can you do before you multiply? You can by, what do you call that? Canceling. Is there anything I can cancel here? 3y. Yeah, the whole 3y, and what does that become if it's?
4y. Oh, well, just like 1.
Okay, let's take it one step at a time. Can the 3 and the 12 cancel? Yes. That gives me 4, that gives me 1. Can the y's cancel? Those are completely gone now. What am I left with here? 4 times 10, which is 40. Do you see how the 3y canceled out with that 12y and gave me 4? Okay, 4 times 10 is 40. That's a lot easier than 10 over 3y. Okay, let's look at the second term. Notice the negative sign. My answer is going to be negative, but go ahead and cancel anything that can be canceled. The y's can cancel. Anything else?
The 2 and the 12 equals 15.
Good. What do I get for the second term with its correct sign?
30.
Negative 30 or minus 30. Yep. Negative 30 or minus 30. Okay, second term is done. Third term or last term on the other side. So 12y over 4. Can anything cancel here?
Yes.
What am I left with on that last term?
3.
3y. Okay, look at the original problem on example number 1, and then look at this problem. They're the same value, the same exact value. Which one's easier to deal with? He's like, oh my, I hope not.
Oh, yeah,
They're all the same. The thing that I changed was I multiplied everything by the LCD, which got all those denominators canceled. Didn't all the denominators cancel out completely? And this is what I was left with. So now, my third step. It's very deep, guys. Solve. Solve. So here it is. 40 minus 30. I'm just rewriting it again. Equals 3y. All right. You want to simplify both sides. So you want to make both sides as simple as you can. What's 40 minus 30? 10 equals 3y. How do you solve for y? Divide by 3. I get 10 thirds equals y. That's the answer. Yes, it's that nice. Could you have worked this problem out without multiplying everything by LCD? Yes. I don't even want to go through that because it's very complicated. Very long expressions, canceling this and that out. No, get rid of those denominators. That's the answer. Okay, look at the problem again. Example number 1. Is there any excluded value for y? Is there excluded value for y? On example number 1. What can y not be? Okay, in this case, y cannot equal 0, right? Does y equal 0? We're okay. Right? We're okay? That's it. Wow. Page 699, please. Page 699. Let's try out number 6. And I'll show you how I work this one out without having to write all those steps. As in, I don't have to write, simplify each term, solve. I just kind of do it. Hopefully with you. Number 6. This is how I want you to start off, guys. So it helps you out to not make it really long. Write out the original equation and give some spacing to it. So I'm going to put here 1/5, and I have some space to the left of it. Then I'm going to put the plus sign, some space, 3 over 2y. See, I'm leaving some space here. And then the next one equals, I'll get that in just a moment, 3 over 3y. I left some space. I'll show you why. Hello? Hi. I'm so sorry. Yes, I did not mark him absent because he wasn't here this morning. Yes. I'm sorry, Shirley. Yeah, and I should have sent an email. Oh. Okay, thank you. Bye. Oops. Okay. What is the LCD of those three fractions? So I put it off to the side. What's my LCD of 5, 2y, and 3y? So think just the numbers. What's the LCD of the numbers? 5, 2, and 3. 30. Mm-hmm. And then the variable part, 30y. That's the LCD, 30y. So this is the smallest number, the least number, that all three of these denominators can fit into. Okay, so what should I multiply every term by? So I'm going to go 30y. See that space that helps me out? 30y. 30y. So that's what I did the spacing for, to give me room to fit in the 30y multiplied by everything. Okay, first term. I'm going to simplify each term now. First term. What's 30y over 5? Yeah, go ahead.
So 3 or 3y, you just simplify it?
Yes, yeah, you can say, oh, that right there? And let me make sure I wrote it down right. Yeah, you could have said 1 over y.
Yeah, and that would make it.
Thankfully, we're okay with that. But yes, you could do that. Yes, you could. Or make it 10y, multiply everything by 10y. You're good. Can I, okay. Anyway, here I can cancel out the 5 and I can make that a 6. So what's this right here? 6y. 6y is left over. Here I can cancel out the 2 and that make that 15. The y's cancel out completely and I'm left with positive 45. And then the last term, the 3 and the 30 cancel and the y's cancel out completely. I get equals 30. And then Josh, remember how you could cancel the 3? What comes out of all 3 of those?
3.
So you can factor that out. So that's good. Okay, how do I solve for y here? You first subtract 45 from both sides. You get 6y equals negative 15. And then divide both sides by 6. And you get y equals negative 5 halves. So if you divide both sides by 6, that's okay. You should get negative 5 halves. Okay, which one is easier to deal with? The original equation or this one right here? Easier, between the two. This one is. So all you have to do is multiply by the LCD, you should be okay. Negative 5 halves. Okay, is there any excluded value in number 6? Any excluded value? What can y not be? Okay, is y 0 in this problem? No. So we're good. We are good with that. Why do I keep asking that? Example number 2. You're lucky you have me on camera. Okay, let's go with the next one here. X over x minus 1 plus 2x plus, minus 3. Minus 3 over x minus 1 equals 2. And notice the space I gave because I know I'm going to have to get rid of those denominators. Well, I hope to get rid of those denominators. Okay, what's the LCD of those 3 fractions? Okay, it's the whole thing x minus 1. It's x minus 1. That is the LCD. So what should I multiply every term by? Okay, so here, x minus 1, x minus 1, x minus 1. And I'll show you where a place where it could get messed up if you're not careful. You guys get how? Do you understand how we got x minus 1 as the LCD? Thankfully, it's the same for both. Okay. On the first term, what cancels out? X minus 1. On the second term, what cancels out? Ooh, x minus 1. On the third term, what cancels out? Nothing. Nothing cancels out. What? So we didn't even get something to cancel there? Well, no, you didn't get anything to cancel there, but you made this problem easier. Or what's left in the first term? X. What's left in the second term? And what's left in the last term?
2x minus 2.
Yeah, you use the distributive property there, you get 2x minus 2. Yes, sir? Go ahead. Okay. This is a review of solving equations. You could have said 2 times x minus 1 here, and then you would have had to simplify that anyway, but here are the steps. Simplify both sides of the equation. So on the right side, can I make this any simpler? No. On the left, can I make that simpler?
Yes.
Yeah, I'll make it 3x minus 3 equals 2x minus 2. So I made both sides simple by adding like terms in this case. Yeah.
You can factor the 3 out of the first part and the 2 out of the second one, so it would be 3x minus 1 and 2x minus 1.
Ooh.
And what will you be left with?
Well, will you cancel out the x minus 1?
Okay, wait on that, Josh, because we're going to see something here. But that's good. Man, this guy's thinking. Did you eat your breakfast today?
I did.
Did you sleep enough last night?
Probably did.
Okay, then that helps you out. Imagine that. Okay, then you want to get the variable only to one side or the other. So I usually like making my variable positive, but you don't have to. I'll subtract negative 2x from both sides. And then I'll get that 3 over to that side by doing what? Add 3 to both sides. So that might look complicated, but this is what I do. All right, that's going to be, that's 0, and that's 0. So what am I left with?
1x equals 0.
1x equals 1. So x equals 1. Yes, sir.
So, carving out the strategy Josh was doing, factored out 3, and then you crossed out x minus 1.
What would you be left with?
3 equals 2.
Okay. Do you guys see how I got x equals 1 so far? Guess because I'm going to tie that in. X equals 1. You guys okay with that? I've asked this question in the last 2 problems. I'll ask it again. What can x not be in this problem? X could not equal 1.
Oh.
X equals 1.
Wait a minute.
It's wrong.
It's undefined.
No. We call this right here, and write this word down, an extraneous solution. Write it down, because you're going to see this later. You're going to be like, what's that? It's extraneous. Okay, did we work out the problem correctly? Like, did we use our properties and all that all well? We did. But when we worked out our problem, we realized, wait, if you check it, or if you know x can't be 1, then that can't be possible. And that's because it's an extraneous solution. It's an extra solution that's wrong. Extraneous just means for you guys, false. And remember, if you would have divided both sides by x minus 1, you would have gotten negative 3, or 3 equals 2. That's false. That's not true. There's no solution.
So no solution?
No solution. Nothing. How about this? Put the answer as no solution. There's none. So that's consistent with what we've been doing before. No solution. You work it out, you get a number, and you're like, great, I got it, but it can't be that, so no solution.
Crazy.
It is crazy. You know what's crazier?
0.
Number 10 on page 699. Number 10. Last one we'll do together.
This is more crazy.
Give yourself some space. Okay, and I'm going to make sure I wrote it down correctly, because that can throw us off. Okay, what's the LCD of these 3 fractions? Okay, it's W times W minus 6. Do you guys remember that from the other lesson? You have to get, okay, how many times are you going to use W? Once. How many times are you going to use W minus 6? Once. This is one factor, by the way. It's one thing. You don't just separate it. So it's W times W minus 6. Okay, so what do you do with everything? You're going to multiply every term by W minus 6. Everything by W times W minus 6. W times W minus 6. W times W minus 6. Oh, man. It's too much. Well, it looks like it's too much, but you'll see what happens here. Okay, do you guys understand if you can find the LCD, you multiply everything by the LCD? So far on these equations, that's what you do. Okay, I want you to be very careful. Do you see W minus 2 in the first term? That's one factor. Keep it together there. Keep it together. And W minus 3 is also one factor, so keep it together there. What cancels in the first, and I'm going to erase this here. What cancels in the first term? W's. Uh-oh. Nothing else cancels. What do you use here?
Multiplication.
What kind of multiplication?
Foil.
Foil or distributive property. Yep. Foil or distributive. So can someone foil this for me?
W squared.
No pun.
W squared minus negative 2W.
Yeah, I guess I'll go in that order. Negative 2W.
And negative 6W.
Plus 12. Oof. That's a lot. Okay. Oh, yes. What cancels out of the second one? W minus 6. Okay, now, listen carefully. Look up here. Look at this little marker here. It's negative W times W minus 3. Not just W times W minus 3. There's a difference. What's negative W times W? Negative W squared. What's negative W times negative 3? Positive 3W. If you change that sign to negative, the answer is going to be wrong. That sign right there. That's it. Mess it up. Because it's negative W times negative 3. Be careful with those signs. I need you to work this out by writing it down, please. Because if you don't, it's very easy to say negative W squared plus 3W and move on, and it's wrong. What cancels out of the third term? W. So 1 times W minus 6 is just W minus 6. Uh-oh. I'm going to simplify both sides. The right side is as simple as it gets. But the left side, can anything cancel? Anything add together? I hate those W squares. I hate them. Wyatt.
W squared and negative W squared.
Oh, these cancel each other out, so the W squares are gone. Okay, now we have 3 W terms. So it's negative 2 plus negative 6 plus 3. Oh, no. Don't think GCF right now. We're just adding like terms. Negative 5W, and then 12 is by itself. All right, go ahead and solve it from here. It did, right? It went from very complicated to still more complicated to, oh, things are canceling down, and that's nice. So your choice, you can add 5W to both sides or subtract W from both sides. And then you can keep working it out. But you should all get the same answer if you worked it out correctly. Okay, hold that thought. How many of you are adding 5W to both sides? Like that's, how many are subtracting W from both sides? How many of you are not doing anything?
I got it.
You got it? Okay, on the count of 3, give me the answer. On the count of 3, give me the answer. 1, 2, 3.
3.
It's 3. But is 3 allowed to be a solution? Oh, it could be here, and it could be here as 3. Fine, 3 is the answer. What can W not be? 6 or 0. It can't be 0 and it can't be 6. Those are the no solutions. Thankfully, it's not. All right, celebrate with this, guys. 17 to 31. Oh, sorry. That was emphatic. Too emphatic. Goodbye, Swivl.